This is the hard lock nut design, based on the wedge effect principle, providing the most powerful self-locking force. The Shinkansen, bullet train, one of the fastest and most reliable high-speed trains in the world, is a symbol of Japanese industrial technology. The passenger transporting vehicles on which various traffic control equipment is mounted and the rails supporting the vehicles are constantly exposed to harder vibration and impact than we imagine. Normal nuts may not be able to stand up to such vibration and impact. For safety, lock nuts that do not loosen are indispensable. This is a vibration testing machine conforming to NAS, the National Aerospace Standard 3350 and 3354. Now let us examine, using this machine, the locking force of normal nuts, double nuts, and hard lock nuts. We have put a mark on the hard lock nut. As you can see, the normal nuts loosen in 20 seconds and the double nuts in 30 seconds. These nuts, even when well tightened, do not assure safety. On the other hand, the hard lock nut remains unchanged after a specified lapse of 17 minutes. You can see by the position of the mark that no loosening has occurred. We will now explain the mechanism that creates this self-locking energy. At the beginning, we talked about the wedge effect principle used in the nuts. What is this? The wedge is an ancient piece of technology coming from the wisdom of our predecessors used to bind two pieces securely. As shown in the figure, forcing a wedge into the gap between the bolt and the nut makes for perfect tightening. This method, however, from the standpoint of operability, is not satisfactory. The solution is to use two nuts to play the role of the hammer and the wedge respectively. A small irregularity in the sliding part of the convex top of the lower nut acts as the wedge. When the concave upper nut is tightened, a powerful locking force is created. The lower nut, slightly off-centered, acts as the wedge, and the upper nut acts as the hammer, driving in the wedge. A paper released at the 2005 ASME Pressure Vessels and Piping Division Conference held in July in the USA testifies to the hard lock nut's anti-loosening capability and is confirmed by the three-dimensional finite element analysis. A normal nut slowly rotates reversely when a huge impact is applied to the bolted joints in a perpendicular direction to the bolt axis. This shows that the nut is loosened due to vibration. You will see that the hard lock nut slides a little bit to the right and to the left, but does not rotate reversely. This is the secret of the hard lock nut, the most powerful locking force in the world, and why it does not loosen with huge impact. So we can see that the hard lock nut's locking force contributes to the safety and reliability of important safety equipment mounted on the Shinkansen. The hard lock nut has achieved a reputation for total customer satisfaction, not only in Japan but also all over the world. The hard lock nut was officially approved by the UK Network Rail in 2003 for use on adjustable stretcher bars. It has also been approved by the Queensland Rail in Australia for use on turnout fastenings. In addition, we have supplied 4 million sets of hard lock nuts for the rail fastening of the Taiwan high-speed rail, in addition to its application on rolling stock. As you may be aware of, Japan often suffers from earthquakes and other natural disasters. Strong wind or rain make nuts corroded and loose. Primarily, things that move by themselves or function while adding accelerated force or stand up to an absorbing impact, for example highways, skyscrapers, industrial machinery, and so on, are affected by nut loosening factors. The hard lock nut supports safety in many places out of our sight. We are very aware of the importance of safety which the hard lock nut supports. Therefore, we make every effort to ensure production control and to ensure severe quality inspection of our products. In order to keep the proven quality of our products, all of our staff are enthusiastic in achieving product safety in every process. We continue to make further improvements to meet the customer's requirements and develop excellent products with new concepts. All of our products have anti-loosening capabilities, effective workability, easy installation and removal, durability, and moreover require less maintenance and inspection. These properties provide the customers with a great economic advantage. The hard lock nut, which enjoys confidence and a good introduction into the market. The hard lock bearing nut, which has been well accepted for industrial machinery. The space lock nut, an anti-loosening single nut with high spring elasticity. The hard lock set screw invented in reverse of the hard lock nut, which has made an epoch-making improvement in the fixing of automotive part molds. The hard lock pin lock bolt for double safety performance, which clears the severe regulation norms of governmental offices as applied to safety in the workplace.